declaring them inside the parentheses of the function definition. Let's take a working copy of func.cpp. We'll use the C++ version this time and paste it into our working project and open it in the editor. You'll see this is exactly the same as func.c, with the difference that we're including iostream up here instead of stdio.h. So let's save this and run it and see that it's working. That's great. And now let's go ahead and pass a parameter. So we'll start by changing our function declaration, and we'll say that it's going to take an int. And so we just put the type inside of the function signature there, and then down here in the actual definition, we can give the int a name. And then we'll just print it inside here. We'll just say I is %d, and put the I in here, and we'll say infunc so we know. And now you'll notice that we have a little bug mark next to our function call here because our function signature shows it with an int. So given an int here, we'll have to define one. And we'll give it a value. And we'll just put that in here. So I'll save this and run it. And you see we are successfully passing our integer value into the function. So in C and C++, functions always pass by value. So what that means is that when I make this function call with the I in it, it actually makes a copy of that I and passes the copy into the function. And inside the function, the copy is called I. And so this is a copy that's being used inside the function. So if I come in here and I say I equals 132, and then after the function call out here, I print it, we'll save that and run it. And you see that this I is unchanged. It's still 7. Inside the function, it's 132. Now, if you actually want to affect the variable outside of the function, then you need to pass a pointer or a reference. And so here we can call this a pointer. We'll call it int pointer like that. And here we'll call it int pointer like that. And now we're going to use what's pointed at by the pointer, not the pointer itself, by dereferencing with the dereference operator. And I need to pass an address instead of the actual variable here. So now I'm passing the address to I, and I'm changing I inside of the function, and so we would expect it to be changed in both those printfs there. And there it certainly is. Now if you're using C++, you can do this with references instead of pointers. And the advantage and disadvantage of references is that the syntax is much simpler. So if I change that to a reference there, here I no longer need to send the address. I just put the variable there and the compiler will go ahead and create the pointer for me. And here, instead of the asterisk, I'm going to have the ampersand for it to be a reference. And now I just use it as if it were a straight variable and not a pointer at all. So the semantics is different. The effect is the same. Save this and run it, and you see we still have our side effects. We're still actually changing this variable, but we just don't have all that syntax around it. The only thing we've changed here is the function signatures. References are available in C++. They are not available in C. Now, function calls always pass by value. If you pass a reference or a pointer, it's the value of the reference or the pointer that you're passing. References make this almost completely invisible and therefore more prone to error, but the function call is still passing a value. Now, given that functions are strictly passed by value, when you're passing something big, you'll always want to use a reference or a pointer. For example, here, if I declare a string, that's a really big string with lots of text in it, and I can pass that as a reference. So now here, I'm going to get rid of that integer, and I'm going to pass my string instead. And here we'll just display the string here. And down here in the function, we're going to take a string instead of an integer. We need to take the C string of the string in order to use in printf, or we could just use a cout, like that. And the same thing here. Here we'll just take the C string of it. So you can see both ways to do that. So now we'll go ahead and compile this and run it. And you see we're passing our string into the function. Now the problem with this is that we're actually passing a reference to the string. And so now it's possible for the function to actually modify the string. And we don't necessarily need for that to happen. So we're going to change our signature. And it's a good habit to get in every time you're using a reference to use the keyword const. And this prevents accidents from happening with side effects. So we'll save this and run it. And we see that that's how you pass a larger object into a function using a reference. Parameters are always passed by value in C and C++. You can pass pointers or references if you need side effects, but you'll need to do it